into other parts of industry, the precision is no longer relevant. And so what happens is tasks that are relatively similar for human beings, human beings can a lot of times look at a video of a task being done for about 30 seconds, and it basically seems very simple that, hey, I pick up an object from one spot and I put it into another spot. So that's a testament to the fact that human intelligence is very, very versatile. But when we think about programming robots to do these tasks, the programming required to make a robot successful grows very, very rapidly with the degree of complexity in the task. So one task, for instance, that we see in warehouses, and we are pretty focused in warehouses, is some items might be coming on a shelf or on a conveyor belt, and people have to pick them up and put them in a box. Second type of task is what we call sorting, where you get a bunch of items and you pick them, you sort them, maybe put them in different shelves or in different conveyor belts. Other tasks, for instance, could be picking items, putting them on pallets, putting them on racks. And so as we shift away from industry, the next frontier where robotics can really add a lot of value has been warehouses. And tasks like this are very complicated to do because the items change all the time. And so what we have been working to do is to try and automate tasks like this. And the challenge with that is automating the task actually requires advanced software. It requires advanced hardware, and it requires people to think in an end-to-end manner. So when I started doing robotics, I was heavily focused on software. Of course, I studied information technology, and at Stanford, I was also in the computer science program. And the mindset of a software engineer, translating that into the real world requires sort of some changes, in a sense that we also have to think about the hardware. And so I think early on, I didn't know very much about hardware, but during my PhD, I had the good fortune of having to build quite a few robots myself. And so it built in this, what we call full stack engineering mindset. And so that led us to the idea that if we want to automate a system, let's think about the entire system and think about comprehensively as a set of software and hardware problems that we can solve. So if we take a warehouse today, and we are very interested in automating warehouses, a typical warehouse might look like this. There are stacks of items lying around, or maybe racks. And normally people walk up and down the rows, and they pick items and put items and all sorts of stuff. And so when we decided to do Dexterity, we said, hey, we have to have our robots be smart and pick. We also have to have our robots have the capability to place and to move around. And so we add some conveyor belts, we add some rails so that the robots can move. We add some small robots maybe to pick small items. We add big robots to make pallets and pick big items. We add some grippers. Now, the human hand is very versatile, very powerful. It can pick up just about anything. But there's also another idea, which is even if we take somebody's hand and tape it up completely with the fingers, a human being can still take something like a spatula and, with a spatula also pick up items or scoop up items. And so the idea with that we came up with is we got to have the hardware that is necessary to do the job, but a lot of the complexity should be handled in the software. And so after provisioning some basic hardware, we work on the machine learning, the computer vision, the intelligent control, and that allows the robots to look around themselves, see the environment, pick up items and place items. And at the very, very top end, we add what is called fleet orchestration. And so fleet orchestration is teaching the robots how to collaborate with each other, teaching the robots where to go, doing scheduling, to do dispatch, to connect with other database systems, so that when orders come in, the robots know which order needs to be filled in what way. And so what happens as part of this process is we take a warehouse that used to look like this, convert it into something that looks like this. This is a very massive change. And just the way Professor Nandi mentioned, a lot of companies have tried to do this, and it's challenging because of the variations in the environment have a very dramatic and substantial impact on the manner in which robots behave. And so things that look pretty simple from the perspective of a human actually require a lot of advanced programming to achieve it from the perspective of the robot. And I would encourage students actually to take a look at the kind of technology that goes into making these systems successful. And so if you are thinking of pursuing certain types of engineering, or if you have a certain type of interest, the one thing to remember is no matter what you're doing, it usually has an application in robotics. And so if you have an interest in robotics, you can go deep into any field and there's an impact. So in this particular scenario, there's an impact from mechanical engineering, from electrical engineering, from battery technology to material science, to aerodynamics of maybe if you have suction grippers, to cameras, to sensors, to machine learning, to computer vision, to advanced control, lots and lots of math, very complicated distributed systems, scheduling algorithms. And so the thing I really like about robotics is it's got a little bit of every piece of engineering in it. And so no matter what your interests are, you can find a very satisfying career looking into robotics. So digging in to these specific approaches that we use, we've used what is called hardware agnostic sort of model-based control. And model-based control essentially relies heavily on nonlinear dynamics mathematics. There's a certain branch of control theory where what we try to do is take the robot sort of out of the equation and let the software work with perfect idealized robots, or AKA models of robots. So one of the great inventions in computer science was the fact that when we had computer chips, there was an abstraction layer in terms of the baseline programming language. So today, if you're programming in C++, you actually don't care about the processor that you're programming on, because there are compilers which take your C++ and compile it to any processor. And so the heavy lifting of the machine code is done by the operating system and the compilers. And so in the same way, in robotics, what happens is if you want to write a computer program to engineer some sort of motion or some sort of picking capability, the compilation process, taking an abstract sort of high-level program at the level of the robot hand down to the motion of the machine, is what was really missing. And so that causes a lot of work to be done, even if you make small changes into the robot's motion. And so one of the things that we worked on was to add this sort of robot agnostic layer, which is essentially a lot of mathematics and a lot of physics-based models that allows us to write complex programs at a high level and to focus the machine learning on the task and not the complexity of the hardware of the robot. So that's one interesting thing. But when we really take a deep dive, like I mentioned before, robotics is about a lot of things, and you can go all the level from mechanical engineering on the left when it comes to different types of grippers or automation equipment to sensors. These are different types of sensors like force sensors, tactile sensors, grasp sensors, cameras, to mobility, where we now study motion planning, we study human-robot interaction, to control, to computer vision, software and simulation. And so a lot of this comes together into a complicated system. And I have a few videos to show to kind of give an idea of what the robots can do now. So here's one video. It's a pretty short, high-level video. But one of the first challenges with robotics is that robots need to be able to pick anything and everything. And so I'll play that back again, except in slow motion. And so notice over here, a robot is actually picking up a cup. Now, when the robot comes, the robot doesn't know how much force to apply. If it applies too much force, the cup can break. If you notice, if it pulls it up and it bumps it against the table, the cup can break. If it moves too fast, the cup might slip out and fall. And so if we move away from maybe a cup to a block, to a chocolate bar, to maybe some candy, to chips or whatever this is, I don't know what it is, to bubble gum, cosmetics or glue. The idea is these are objects that have never been seen before. And so the robot simply has a camera. It has the ability to find some geometric shape, to maybe find some color, and it needs to intelligently understand what is the right way to pick these objects, what is the right amount of force to apply, at what speed can I move. And so all of that happens in real time, and the robot goes ahead, it comes in, makes a pick, and it moves. And you'll notice over here that the gripper is sort of a finger-based gripper. That's one type of gripper. It has its own properties. In other situations, we use what is called a suction gripper. And so over here, the robots are now doing a task that is sorting some parcels. So anytime you go to a courier shop, or you put some items in a bag or a box and you parcel it from some place to another place, between the time you actually give the parcel to the courier shop and the time it is received by somebody else, on average, it's sorted about 30 times. And so there's a lot of work that goes into even making a piece of email, like a physical mail or a parcel, go. And these robots over here, basically what they do is they come and they look at a random pile of parcels, they'll pick them up, they'll scan the barcode, and they'll integrate it with some sort of system that puts it somewhere. Another application that we are very interested in was when stuff is made at a factory, it's before it's shipped out, it's actually assembled into what are called pallets. So you have a bunch of boxes that are assembled together. And if you look at it, it's, ouch, what happened here? Oh. And so this particular thing actually becomes a little bit like playing box Tetris in 3D. And so if people are familiar with sort of integer style or like whole number style packing algorithms, you'll know that this kind of stuff is NP hard. And so if you get a random sequence of boxes and your goal is to pack them with a high or optimal pack efficiency into a big Tetris style Padlet, it's basically impossibly hard. And so over here, the point over there is that there's approximation algorithms that go into this. There's, in addition to that, why does this keep skipping the slide? In addition to that, there's the ability to pick and place and have a gentle sense of touch and pack. Over here, the robot is now packing basically biscuits or bread. And packing bread was actually extremely hard because you kind of have to tuck it in. Over here, two robots are working together to pick trays. So this was a pretty unique ability. I'll play that back again. And let me just play this in slow motion and point out a few things. And so over here, when two robots come together to, say, pick a tray, what happens is, and again, these are the kind of little nuances that make robotics hard. So the tray is flexed a little bit. So there's some mechanics in the tray. It's bent because the bread in it is heavy. We don't know how much it's going to bend. We don't know how much it's going to flex. If it flexes a little bit too much, the tray on top is going to pop off. Over here, the robot comes it puts its hand into the slot. It has to apply some pressure in the slot because the other side the robot is applying some pressure. These two robots are independent systems. They are running on separate computers. You have to synchronize across the computers. There's latency in the network. All of those things can cause even a few milliseconds of force being applied too late, and the whole thing falls down. And so over here, you can't even see the pallet properly, and so you have to rely completely on touch perception, which is pretty hard. So multi-robot collaboration is actually considered an unsolved problem even today. And I think we are doing some of the most interesting work in multi-robot collaboration right now. And so all said and done, when we look at our systems, really the goal is to have full stack and end-to-end systems. And here's another sort of demo of what it means to have this full stack type of system. So what you're seeing over here is robots are working together, 4 of them, to pick bread and pack bread. And this is a system that we've actually had in production. It was interesting because when we put this in production, the coronavirus hit, I think a few months later. And one of the first things that happened after the coronavirus hit is in the US, all the warehouses started shutting down because warehouses have a lot of manual labor, and they really, coronavirus spreads pretty easily. And so I think we were quite fortunate to have robots over there, have a productive role, and do things like pick and pack bread. And so systems like this, are the next stage of robotics, going away from factory automation into sort of intelligent collaborative robots that work with each other, that also work with human beings. We're continuing to make steady progress, and hopefully one day, we can take these robots out of the warehouses as well, maybe bring them into offices. One day, maybe take them out of offices and bring them into our homes. And then it can do all the work for me, so I'll be quite happy. I won't have to do any more work at home. So if you look at the background, people were actually quite excited when this worked. So this was, one of some of our colleagues and customers. So that was pretty cool, and it's a long video. It keeps going, but I think people can get the point. And there's more on our website if you'd like to go and check it out. So what are we doing in robotics? I think one of the things I did want to share was when I was doing my BTech, there were many career opportunities available, but we never even thought about doing a startup. And we always thought about maybe taking a job at some company, and that is very rewarding. Of course, I started working at Microsoft, and Microsoft was a fun place. They do some excellent software engineering, but the idea of working on the cutting edge of technology was also very appealing. And I think startups are something that I would sort of propose is a valid career path. It takes a lot of preparation, a lot of hard work, and the vision really should be to have a transformative impact on some sort of essentially a business. And to end, what I'll do is I'll maybe share our idea of where we are headed. And so where robotics came from is what we call level 1 robotics. Level 1 robots were typically what we would call a robot in a cage or a robot in a box. These are robots have been around since the 1970s, 1980s. You program them once, and they do a certain job. The job is usually some sort of mechanical labor, and they do it very well, and they do it again and again and again. And so the great feature of level 1 robotics is precision and reliability. So the robots are very precise and very, very reliable. A massive step up from level 1 is what we would call level 2 robotics. Level 2 is the intelligent work cell. And so it expands upon level 1 by adding things like machine learning, like computer vision, maybe some degree of contextual awareness and human-robot interaction. A pretty massive step up. The nature of the work, though, is still sort of an isolated little work cell where some sort of mechanical task is done again and again. The next level up is when you actually have a team of robots, and all of a sudden, in level 1 and level 2, the robots are always working by themselves. They're not collaborating with other robots, and so the programming tends to be, a little bit easy. If all the people over here probably know, if you have n robots and you have connectivity between them, you have n square potential interactions. And so the moment you have a collaborating robot team, the complexity of the problem grows as a quadratic with the number of robots. And it's interesting to be able to sort of take these robots, load balance across them, resource share across them, and there's many, many technical improvements that can be done. The next level up from that yet is now when we have not just collaborating robots, but also collaborating robots and collaborating humans. And so this adds another degree of complexity in that we have to worry about safety. We have to worry about how humans are going to perceive the robots. We have to improve the efficiency of the robots and the humans together, which means there needs to be very efficient human-robot interaction. And the next level up even from that is what we will call transformation, where you completely reimagine the entire workflow. And so industrial automation has been around since the 1980s. It's still sitting at level 1. There are a lot of startups now that are starting to do level 2 stuff. Dexterity, the bread system that you just saw, is actually at level 4. And we are inching closer to level 5. And the great part about robotics is, it doesn't even stop at level 5. And you actually can go even one step up, where now you start automating entire industries. And instead of having, a single building level transformation, you have an entire country or entire industry level transformation. And at this point, I'd like to share a thought. I think when I was younger, the idea of complicated businesses always seemed very scary to me. And it was very sort of easier to comprehend a path that was done by many other people. And at some point of time, we started to realize that a lot of the transformative impact that is actually had when we take very difficult problems. And robotics is indeed a very, very challenging problem. When we look at very difficult application areas, and improving efficiency in supply chain is a pretty large, complex application area. And we take technology that is yet to be developed, but we can think about it, and we work hard to make that technology a reality and apply it to the application area. And once it starts to work, it's unstoppable. And so this was a pretty novel career path for me. And having been working at our startup for a few years now, it's been intensely rewarding, and I would encourage everyone to think about it. So when we think of robotics, again, going back, there have been assembly robots since the 1980s. There have been mobile robots since the 2000s. And they're dexterous robots today. So I think I'll end here. I'm a little bit over time, but thanks everyone for listening. And I believe we have a small QA session after this.
Well, great. Thank you.
Okay, thank you, Samir. So people, if you remember, when registering, we asked you, what would you like this webinar to be? And we got great questions. So that's where we've got the second part, which is the panel discussions. And to take it further, of course, we have Samir, and he will be joined by Professor Nandi, who's not only sculptured Dr. Samir in his initial days, but it's also behind a lot of other great students. So he understands the Indian perspective, the Indian startups, as well as the Indian culture. And we've got a big list of questions. I'll take the most fundamental ones up for the panel discussion. So first to Samir and then to Professor Nandi, interesting question. So this is about life and culture. There are a lot of senior faculty from all the institutes around India who would like to know what role did Stanford play in the life and in the decisions that you eventually ended up making. And you've also spent time at IIIT Allahabad. So what role did IIIT Allahabad play? And what could we learn from Stanford to develop the culture and producing interesting personalities like you? So Samir first, followed by Professor Nandi.
Oh, so many questions you asked, I forgot already many of them. Go ahead, Samir. Please.
I'll maybe summarize the question. I think it's, what impact did IIIT Allahabad have on the development of students, and what are the differences maybe between the Indian style of doing things and the American style of doing things at Stanford, and what can we transfer from one to the other. So I would say, to answer the first part of this, I think IIIT Allahabad was an excellent institution. When we joined, the campus was actually under construction, and it was a very new college. Yeah. And so anytime there's a new sort of beginning, there's also a great opportunity to do things in a relatively free manner. And I think what we really benefited from was the faculty and the administration were deeply committed to developing the college, and we got a lot of resources, having computer labs where we could have access to computers, eventually having sort of advanced set of courses, which was very beneficial, I think, to inspire us to try and do things. Just the name and the brand of IIIT itself was quite well received, I think, internationally as well. We applied for internships. I think those internships to other sort of institutions abroad were very consequential, allowed us to get more recommendation letters, get to Stanford. And so finally, I would say the students were also very smart, deeply committed. Almost everyone that I know from my batch is doing very, very well today. A lot of them are actually in the US or in India in excellent positions. So I would say IIIT is outstanding. There was deep commitment from the faculty to personally develop the students. Students did very, very well, and so that was great. Stanford, I think, brought a few things. One of the first things I noticed when I got to Stanford was I understood the meaning of time. I think one of the things that we had in India was, oftentimes you have a certain amount of work, and there's a workload, and you get it done. I think it's possible. Everyone knows that as long as you put in the effort, you'll get your work done. When I came to Stanford, I realized even if I put in 100% of my effort and I don't even sleep for 1 minute a day, I still won't get my work done. And so just the amount of stuff that they put on your plate is just, it's crazy. And so I think that was a very unique experience for me, because I was used to being, one of the top students in the class, and all of a sudden there was just so much work that no matter what I did, it was impossible to finish. And so I think it adds a certain degree of discipline, which forces us to be selective about where we pay attention, which forces us to really pick and choose areas of focus where we can have a solid impact. And I think that was a great thing. Apart from that, I think there's strong connections with industry. There's much more monetary resources to have better infrastructure, and I think those are things that eventually I think will also come to India.
Well, great. So I would like to add something, as Samir told that yes, during those days we were developing, so everything was in a fluid state, and my students, they're brilliant, and they were actually, I think, from IIT interns we picked up those days, and you tell them little and they will do it like this. So we tried here to give them some kind of platform where they can have some test about new technologies. In the name of Robotics Club, we tried to give them an extra opportunity, and in a very humble way, we tried at that time, and now it's a center. We have, Samir is telling now level 4 or 5. It is the era of cobotics, means robot and human will coexist, and robot merely work as a tool, greater tool of human. And it's amazing for me to see so many of you are doing so great there. No, Alok Parlikar is there, you are there, then Bhaskar in Amazon, Bhaskar Gupta. He's doing a wonderful job in warehouse robotics. Actually, they were taking robot as a service from companies, many companies like yours companies and all, and they are trying to use it. And your job is to provide that foolproof technology. As you said, dexterity is very complicated. We know we are doing research in one of my students is trying to do the manipulation task using reinforcement learning. Learning has to be there. This concept I was propagating in our country, I think from 2005 onwards. Wherever I went for giving a lecture, I told only mechanics, dynamics, fixed control, base, robotics, the time is over. Robot has to have learning. Otherwise, slight change in the working environment, system will fail. So now it is picked up, and you have demonstrated that what dexterity can do. And I think this is a long way still to go, because for many environment, the requirements from your Dexter robot will be different. Vision may be very difficult one when you are trying to pick up glass of water or something like that, and you know it. So, and I think we should now focus to our student to tell that getting job from the campus is not the only way. Look at Samir, look at Bhaskar, look at them. You'll have to create job, and robotics is such a wonderful area, fascinating, challenging area. You can test your skill in doing something new. And I hope that one day you will visit India and visit our center now, Center of Robotics. We have, great thinker Rodney Brooks. He developed Rethink Robotics. But this idea was great. The Dexter he created, and we have one Dexter, but the company unfortunately is gone. But idea was great, that we'll have to free robot from cage. We'll have to bring robot as a collaborator for human, where human will feel he is my co-worker. So thanks, Samir, for actually throwing some light in this direction. And through you, I am congratulating all our alumni who are doing wonderful job in the Silicon Valley and Washington, D.C., Washington State, Seattle especially, and Redmond. Thank you again. And I now open the forum because many other...
I think I'll take in the pre-decided question first.
Okay, so...
for the panel discussion. So, Samir, the second question is more that represents the students in bulk numbers in the audience, and imagine them as people who still work on Raspberry Pis and Arduinos to make things like line follower, maze solver. And of course, the reason for taking extra pains is to become you eventually. So what should be the learning? How much time should they devote to that? Do you recommend technologies? Do you recommend problems? What is the roadmap for these people?
Raspberry Pis are awesome. I love those Raspberry Pis and the Arduinos. I think building anything is really fantastic. There's so many resources on YouTube. There are programming resources. There are resources on how to make hardware, on how to sort of integrate systems and sensors. I think a lot of the hardware is also getting quite cheap now. I think things like your Arduinos and Raspberry Pis are pretty low cost and a relatively small budget. One can go ahead and make things, I think, buying. So I think those are all there. That being said, hardware is still a little bit tricky, and but for that, I think it's also possible to use software. During my PhD, I actually worked on a software simulation system, which is now online and free, and anybody who wishes to use it, it's pretty easy. At least the basics of robotics and control can be done there. So I think there are many avenues to do it, and people should focus on what they are interested in.
I think Professor Datta from IIT Kanpur, he is also attending. Professor Datta, are you here? You had some question? No? Professor Datta?
Okay. No, I don't think. He's not with his screen name. So, Professor Nandi, quickly upon you, that you are behind a person who ended up being Samir as we know today. What should young kids with Raspberry Pis be doing and learning so that they end up with a similar career?
Well, first of all, not I am only behind him. He himself is ahead of him. So Samir has a great zeal of doing something, venturing out something new. That zeal is very important. One of my students actually, after I circulated the mail of Samir's success, he wrote me, "Sir, I want to be like him." Then what to do? I told you will have to you will have to do what you are doing, and you will have to stop dreaming in the night, as our former President Kalam told. That you have to dream in the daytime what you want to do, and vigorously you will have to pursue. There are lots of opportunities. Just last week, one of our alumni again, he told, "Sir, I have left the job and I have started a company." So those kind of things, you'll have to venture it out. You'll have to take risk, and then you will see a lot of opportunities are there. So my advice to my students, current student of IIIT and other institution would be that pursue your dream. Don't waste a lot of time. Sometime, yes, fine, for a campus job. Basically, they are only psychological satisfaction. Someday you will feel, oh, 4 years I spent not for doing this. I would like to do something new. So that thing you'll have to realize. More quickly you realize, better is for future. Okay. That's my...
Wonderful. So I'll do one thing. I'll just take 2 more questions from the pre-decided list. And after 2 questions, I will set the floor open for the audience to ask questions. I'm sure there are many. So the first question that we get a lot in India is, what is the tipping point? And usually you are to tip from a regular business, a regular job at a white collar industry to a startup. And then you start worrying about a number of things. Will this really work? Is it too much of a risk? What if the idea is completely behind? So Samir, if you could personally say that, did you have these things in your mind, and what was going on, and how did you eventually decide that, yes, I'm going for it, after which there was no turning back? So could you explain that phase of your life?
Could you recount the 3 things again, please?
So imagine a student sitting in this panel who wants to operate a startup and has a job offer. So what would you tell him? How to overcome the risk, how to verify the idea, and how to tip beyond a point such that after that there is no turning back with your personal life experience?
I see. It's a challenging question. I think there's here, maybe I think I'll share my screen and I'll draw a little thing. It might make it easier to sort of explain. And so when we look at startups, I think one of the classic things that happens is it starts with a person who has an idea, whatever, right? And that idea goes into a space of technology, and typically the person is pretty good at doing things in a small space of the technology, and then they go out and see the space of problems, right? Or maybe customers. And the classic idea that happens is, hey, I'm really good at this like tiny little thing, but somehow it's going to be really useful for everything, right? And so this is called a hope. And so this is where most startups like fail because reality is a little bit different. And so I think if somebody wants to do a startup, the first thing I would say is start with a problem. And so if you start with the problem, what you will find is to actually solve the problem, you need a pretty wide set of skills. And so once you have a wide set of skills, what you'll find is it's impossible for any single person to have them. So if you have a good set of friends or a team, maybe somebody does that, somebody does that, somebody does that. And, if you can sort of collect together a set of people so that combined, they can actually go ahead and build the product or the technology which solves the problem, I think then it's worth it. And so to answer the original question, it wasn't just me. If it was just me, I would have basically gone and tried to do this method, and then it would have failed, because typically what happens is when we look at this set of problems, solving that set of problems actually requires pretty much all the technology in the universe. And so it's very tough, especially in robotics. And so I think for us, the idea really was focus on a problem that we can solve, focus on a problem that actually adds a lot of value, look at the entire set of technology that we need to solve it. And if you look at a problem just like picking bread, you'll find you need robots. I showed that list, right? You need pretty much everything in engineering already. And so it's getting the set of people, the team together. And if you have all of that, it makes a lot of sense and you should go for it.
Okay, I'll get in on the last one. So a debate that is actively going on in India is that, yes, everything leads to robotics and we need robotic solutions. However, there's also a cheap labor market, as well as the fact that does India really need deep tech startup, or should somebody concentrate more on low tech application based startups? So as people who still don't have ideas over here and took you as an inspiration, and after the meeting will start thinking about new ideas, for the Indian market, do you suggest deep tech, high tech, low tech, robotics, non-robotics, or in your neutral view from the West, if you have interesting problems that these kids should be working at right after the session?
I think it really depends on people's interests. Like I would say, no matter which part of tech you go, if you dig deep enough, there are unsolved problems. I'll give you one instance. When I was an undergrad, I used to think like processor design was just, like it's kind of done. They've been working on it for 30 years. What else can you do in processor design? And I was really interested in algorithms and AI. And then I realized like processor design is not done. There's probably 50 years more work to be done in processor design, maybe hundreds of years of work. And at some point of time, I used to think that, oh, hardware is very easy. And then I built robots myself, and I realized hardware is not easy. The hardware is pretty tough, and it's also very, very important. And so another point of time, I used to think like logic, oh, you know what, like people have been studying logic for thousands of years, what else can you do in logic? And then you study logic a little bit and you realize, oh man, there's so much to do in logic. So I don't think there's, I think this deep tech and hard tech, whatever, these are like fads. Human beings have been working on technology for thousands of years, and this is going to continue. And so find something that is very interesting, and if you dig deep enough, there's amazing, very, very interesting and challenging problems. And the simpler the field, the harder the problems are.
Okay, I think I'll have Professor Nandi's quick view on what problems should these kids be solving and what should they learn. And then, of course, we'll have Ashish Datta, who will ask the same question, that what should the kids be doing who have all these inspirational people on board. So Professor Nandi followed by Professor Datta.
Well, Dr. Kala, as you told that what is robotics in Indian context, I believe the technology, high technology, robot categorized in high tech, in India, it has lots of scope because we ignore many jobs which should have been automated. I will give you an example. Scavenging, the way people do it. Do you know how long India can be a country like this where human values, human lives, human safety doesn't make any sense? So once you are talking about human safety, cleanliness, all kind of things. You see today in COVID situation, in shop market and everywhere, if you see the kind of manipulation they are doing, as Samir told, there are lots of problems. And problem is Indianized problem, I believe. But the technology solution could be a robotic solution. And there are so many problems which can be solved. They need not be $1 million robot. That actually, I think, Dr. Menon's job to figure out the specific robot as service for Indian scenario. But our young minds should think about the problem. And networking. Problem cannot be solved by a single person. Isn't it? So if the problem they realize and they can have a networking people to work for them, then lots of solutions should be done in Indian context as well. Okay. That's my opinion.
Yeah.
Okay, Professor Datta, we had a little discussion where we need your inputs, that they are kids. What should they be learning? What should be their roadmap so that they eventually get making interesting solutions for India? And then, of course, you can directly ask your question to Samir.
Yeah, okay. So, Samir, thank you for a very interesting presentation. And yeah, so this question of dexterity has been going on and on from 1960s, maybe.
Yes.
Right? I think at Stanford, it was Mark Katowski and others who started about sensors, and then it is on and on. Now, in terms of this dexterity, one is purely from the research point of view, that it involves solving problems in terms of physics. By physics, I mean interaction with the world is through sensors. In our hands, we have different kind of sensors, which a robot doesn't have. A robot basically just has touch sensors, and that's about it. Whereas in our hand, we have different kind of sensors. We have touch, we have slip, we have vibration, we have all others, temperature, shear force. Okay, so one is the physics of the problem. I think Professor Alison Okumura and they work on different kind of sensors. Okay, so that's one side of the story. The other side is the hardware, actually, the hardware of the robot. Then the other is the software, and then learning. Right. So an integration of all this together is what makes up a very dexterous system. The ultimate, of course, is a human being. Right. So now to answer the question that what the student should be focusing on is actually not very easy, because you have to focus on all of this. Right. Yeah. You need sensors, you need hardware, you need software, you need learning, and everything packaged together is giving you an intelligent system.
Yes.
Right? So in a way, as Professor Nandi was also mentioning, that there are a lot of challenges in India. We can start off with very simple things, and in India we have started off with educational robotics, with the small robot kits which teach programming. You can buy an Arduino processor for 500 rupees and do some kind of very simple programming and get things done. So there are small companies which have started off with vacuum cleaners. So I think from students' perspective, right from the schools, this is already started off. Okay, that using robotic kits and robotic toys, and try to get them working in the real world problems. The interesting part is that a robot essentially has a controller, which is 500 rupees these days. I mean, a very cheap one. Okay, and there are sensors, ultrasonic sensors, touch sensors, which are again 150 rupees. Then you can make very simple motors, or you can buy motors for 150 rupees again. So essentially, to make a small application or a very large application, it is essentially sensors, actuators, and controller. How you package this. So you can start off with from a very, very cheap one, which a lot of companies in India are doing. And I think there is a lot of interest in Indian students, right from the schools to colleges and onward. Okay, but in terms of research is something where we need to really focus on. That is something that is still very much missing, I think. That if we talk about how many researchers in this area of dexterous manipulation in India, I would say hardly 3 or 4. Okay, so that is something that is missing. And that is where I think we really need to step up. That if you want to bring robots into the real world, okay, that interface, you talked about level 1 to level 6. Okay, hardware robots are always there, but what is not there is that interface. Okay, so that is something that we really need to do in terms of research in this country. Okay, the toy robotics is going on. Schools, colleges are really taking interest. A lot of companies have come up, startups, lot of startups, okay? And a lot of interest in terms of, I think some startups in terms of this factory automation, warehouse automation are already there in Noida, Gurgaon, Bangalore also has. TCS also has gotten in a very big way. Okay, but that interface is something which is missing. Okay, so you had worked upon haptics and using fMRI data, how to correlate. So a lot of the things are still unknown. Okay, and what I personally think is that the physics of the problem is something we should look at in terms of physics. Okay, it's not just a question of applying a robot somewhere. Okay, and unless we can solve that, we will not straight away or really have a dexterous kind of a robot.
I think you're absolutely right. In fact, when we do model-based control, it's basically physics. Like it's almost completely physics.
Yeah. Yes. So thank you for your interesting presentation. Yeah. And networking, we have IIIR, this RAS, which is the UP section. Professor Nandi was the chairman, previous chairman. Okay. So we'd like to organize more of such kind of talks for the students. So if you know of people who can give us contacts, we would be very grateful that we can organize talks for our students and faculty members on the way ahead. Okay, for the world, for India, it's globalization now. Okay, thank you.
Thank you.
Thank you,
And probably agree with everything.
Okay, even though I think Samir has already answered most of the questions, I'll still, okay, Abhinav Bhatta, do you have a question? A quick one?
Yes, sir. Sir, you
Yeah,
just,
you can ask.
if you dive deep into anything, it can lead to robotics. So I have been doing competitive programming for the past 1.5 years. I mean, almost regularly. So what do you think, how it can help me to get into the field of robotics and into the scholarships for higher universities?
I think competitive programming is great. Like it really forces you to build a library of algorithms in your mind for all sorts of interesting tasks. I think it's good preparation. I think being able to program well, having a mindset on how to think like a computer, having a good set of algorithmic things in your brain is excellent. So, like I said, again, with robotics, it's about the team. And so you have to find, you can bring one piece to the puzzle. I'll give you one idea. When I was working on robotics, my core expertise was nonlinear control, a lot of math, and simulation. And so I had to partner with electrical engineers and mechanical engineers and people who were working more on computer vision. And so I think you have to find the team, and you could find the team maybe by joining a university or by working together, building your own sort of colleagues, or joining a startup eventually, or industry. And I know Professor Nandi is taking a lot of efforts to build the infrastructure so that people with different backgrounds can work together. And so I think programming is great, and it's one piece of the puzzle. And
as you are telling, we are surrounded by lots of robots. The Dexter is there, and then
nice.
there is a Locobot, and then a fleet of Now robot, and Dr. Kala has lots of robots. So infrastructure creation is very much important, and so that students can be attracted.
Yeah.
Wonderful. So I think Shashidhar, if you're there, you can ask your questions. I do have, yeah.
Yeah, first thing is I want to ask, how did you manage to get the investment for your startup? And second thing is, what do you think, how is there the transfer of technology from industry to academia? What do you think of it as of now?
Getting funding is pretty hard. I would say it's not easy. You have to have a good idea. I'll tell you the way it works. So the way it works is, imagine you want to give a loan of 1 lakh rupees to your friend who says, I'm going to start a business. If it's your money, you'll want to make sure that you get some money back in the long run. And so in the same way, if you go to a bank and you take a loan to buy a car or to buy a house, the bank wants to get the money back plus the interest in the long run. And so any form of funding which we get, unless maybe it's your parents or somebody who just gives you money for free, it generally has to be repaid. And so the way to get funding is to give a lot of confidence to the person who's giving you the funding that you are going to repay it with with some strong return. And so to learn that, you need to learn a little bit about finance. You need to learn a little bit about what it makes to run a successful business. You need to have a proper plan to actually generate profits. I know in India it's very difficult to have this mindset, but businesses have to generate profits. And if they don't generate profits, then they don't work and they fail. And so having that mindset is quite important. It's tough, man. There's no simple answer. If there was a simple answer, I would give it to you.
Yes, very tough and challenging.
Yeah.
Tough.
Okay, so Anuj Raj, if you're there, we'll take your question.
All right. Hi, Samir. So I would just like to, have a reality check on the state of, on like how far are we with using like dynamic policies and, end-to-end learning when it comes to, even solving like simple problems, let's say, like picking problem or sorting problems. Like how far are we with like end-to-end learning? So there's been a lot of talk around, advancements in reinforcement learning, at least in research, tons of papers coming out, a lot of work on sim to real, like everybody seems to be working on these problems, but when you actually go around solving industrial problems, I have a feeling that we are still, essentially relying on the old school techniques of waypoint generation, and then somehow having smart techniques to just follow those fixed waypoints. And these are of course going to be for like certain scenarios, handcrafted for very specific scenarios. So just wanted to have your thoughts on how far are we, using all the research that is being turned out actually in the industrial settings. So yeah, so some reality check, some insider perspective would be helpful. Yeah.
I actually know most of the people working on end-to-end learning. The long story is it doesn't work. And the short story is they're provably optimal algorithms that do most of it, that are actually computationally efficient. And so there's no reason to do it. There's some nuances of like learning the edge behavior in robotics, but broadly, we're strong believers in physics, in mathematics, and I think replacing physics and mathematics with like lookup tables is like, it's cute.
Okay, so can we have Sneha?
Yeah, so when we are bringing like a new idea or solution to a problem that has been solved differently in the past, then how do we know that this idea is going to fare out actually in reality? Like Segway was supposed to be huge, and many investors had like bet their money on it, but it did not fare out well eventually. So, what are the things that you look for?
I think it's another one of those really hard questions, right? Like ideas are like so different, right? Like I could have an idea that I'll build a spring that launches satellites into space, and it obviously won't work. I can have an idea that I'll write some code to set up a website and maybe do something, and that should obviously work. And so is there a more specific question? This is a very general question. I can't give an answer.
When you roll out the idea, and if the investors think that it's a good idea, then it's not necessary that it will fare out well. So are there any things that you look for when the product is finally out? Like, how do you perceive how the user will
I'll give you an example. There's I really struggled with this, by the way. Is like, when do you know your idea is going to be successful? And so we had an opportunity to talk to some very good investors. And the story I came up with was a little bit like this. So let's say, imagine you are in the desert, and there's like lots and lots of extremely rich people stuck in the desert, right, for some reason. And you are standing there, and you have a big water tanker, and these really rich people are kind of, they're very thirsty. And so, you have a product, which is the water in the water tanker, and there's your market in front of all these like highly wealthy people. And you have an idea, is like, I'm going to sell the water to these people and make lots of money. And so some investor is standing next to you, and you go and tell them, is like, hey, I have this idea that I have this big tanker of water, and those are lots of thirsty, very, very rich people. I'm just going to sell them the water and make money, right? And the investor says like, I don't know, man, it may or may not work. And so you're like, what? Like, watch me, I'll drive the tanker there. You immediately sell the water, and you come back with lots and lots of money. And then you say, look, I proved it worked, right? And then the investor says, yes, I agree, it worked because you proved it. And so the moral of the story is, until you've actually proved it, it doesn't matter. Like, you just have to prove it. And you can't, like, it's not about fortune telling, right? Like, it's about making intelligent guesses and doing the hard work. There's, even if it seems totally obvious, like, it might still fail. And the only proof is actually doing it.
Okay, Anuj Raj has a quick follow-up.
Yeah. Okay. So Samir, so I gather that you say that like all the research direction that you're still taking is like is still far from being realized in the products and also somewhat suboptimal, right? So my question to you over here is that, like me as a student right now, I'm like figuring if I should be taking up the PhD route and working on the similar problems and building up academic credentials, or instead just jump right away into one of the startups and be actually solving, let's say, not as fancy academic problems, but actually some interesting, let's just say some model-based or some control-based problems, and just working on straight away on the product, or taking the PhD route. The goal here is not, like my personal goal over here is not to build like the academic credentials to become a professor or get tenure, but more like ultimately be solving problems. So I mean, what would you do if you were to, let's say, go back 10 years and would you right away jump into solving problems in an authentic startup, or would you still take the PhD route? Like, what are the pros and cons either way?
Yeah, it's a really good question, and let me maybe tweak the question a little bit. I think the question is, when we're at a certain point in our career, there are many options ahead of us, and you can continue to build your skill set, or you can dive in and start doing something, and how much should you invest in what, and should you follow your interests, or should you try to do things that are building a solid foundation? Is that kind of what the question was?
Right. Absolutely.
Yeah.
Yeah.
I think there's it's a very personal decision. I can only give you my own story. So when I was done with my BTech, it was I went and joined Microsoft, and I was really excited because it was one of the best jobs in the country at that point of time. And I think after joining, I suddenly realized that maybe I just wanted to, maybe my foundation wasn't strong enough, and I could have a very good career, but I needed to do a little bit more. And so applied for master's programs, went to Stanford for my master's. Initially, I wasn't sure I wanted to do a PhD. I'd applied for a few PhD programs, a few master's programs, and different schools. I used to feel like Carnegie Mellon had a good robotics program, so I applied for the PhD program there, applied for a master's program at Stanford, because I felt like Stanford was more focused on entrepreneurship and whatnot. And came to Stanford, and then after the master's, I suddenly realized, like my foundation was still not strong enough. And so then I applied to the PhD, and very fortunately got in. And again, thanks to one of the recommendation letters was from Professor Nandi. So halfway through the PhD, and so I think the answer to that is, like, it's not a fixed question. I think it's a question you can ask yourself multiple times in life. And if you take one step and start doing something, it doesn't mean you can't go back to doing something else. And so being open to that change is quite important. Constantly evaluating yourself is important, and you are the best judge, right? Like, nobody else is a good judge of what foundation you need in life.
Just one line to add to it. In India, the undergraduate program, we deal so many things, so it is just an introduction. So that's why my advice was to the students like Samir, who are capable of going deep, they should go for higher study. So you, as Samir told, that you are the judge of yourself. You should evaluate yourself every time. If you think that your background is not firm enough, then definitely you should go for higher study. And you should, means in general, those who can should go for higher study, because BTech is only an introduction.
Okay, so can we have a quick question from Mehul now?
Yeah, sure. Am I audible?
Yes.
Oh, great. So hi, Samir. I'm a final year undergraduate at the moment, and like I'm planning to go for MS. And there's a general doubt when someone goes for MS that should we do a job for 1 year before going to MS, or should we directly go for an MS after completing the BTech? So what is your take on this question?
I think it's a very personal decision. It depends on your interests, on your financial situation. Like when I did my undergrad, we came to Stanford, It's quite expensive actually, and I didn't have any cash, and I was quite lucky to get a fellowship. Without the fellowship, it would have been very tough. So I don't think it's a simple answer. It's a complicated answer that depends on people and their situation.
Okay, good, thanks.
Okay, I'll take in, a question which has mostly been answered, but Shreyas, if you can ask, and a quick comment from Samir.
Hello.
Yes.
Sir, I wanted to ask, like, for example, sir, you were completing like education and you were like in the field of robotics. So, like, how did you actually make the move from to like having an idea like that to implement, but you don't know the broader field, and like to gather a team and to actually get into a startup? So how did you do that?
Yeah, this is a pretty good question. And to give you some context, when I was doing my PhD, I was really on the professor track. Was publishing papers, and like Professor Nandi mentioned, we were organizing workshops at conferences, and doing a lot of the things that were relevant for doing a sort of a professorship in academia. And I think at the same time, I was very fortunate to actually have a very broad skill set. So one thing that I always felt strongly about was maintaining optionality in life. And so you can get optionality with breadth. It's very important to go deep into one or two areas, but it's also equally important to go broad in a few things that are relevant. And so I think having gone deep into, say, controls and robotics, but having gone broad in computer science and math and a little bit of electrical engineering, a little bit of like mechanical engineering, build some robots. And so I think that breadth really helps. And so at one point of time, I felt like I really wanted to make sure that robotics was brought out into industry and not just done at a theoretical level. And so that was the final impetus, and the breadth really helped.
Okay, we've got Professor Vyas.
Okay, thank you, Rahul. So, hello, Samir. I'm Professor Vyas, and we are for last 2 years in IIIT Allahabad developing a new program named Business Informatics, in which we believe that the businesses are moving very close to technology. Technology is getting more business-centric. So we have a new BTech program already started with second batch being inducted this year. We want something like an Industry 4.0, which should give the combination of both the happenings in the industrial world with a possibility to see the influences on business part of it, on the industry part of it. And of course, we every time in every semester, we invite one entrepreneur who is, we would love to have it if it is from the IT, to our business informatics students who are at BTech second year now. So I would like to listen to you on Industry 4.0 and also the major changes, the paradigm changes which the industrial revolution, especially with robotics, is doing in the businesses in logistics and all that.
Yeah, and so for other people, Industry 4.0 is a name given to sort of the next generation of industrial development in a lot of sectors of the industry. And so industry has evolved. They had different versions, and 4.0 is when you have what is called a digital transformation. That means a lot of the machines are now connected to the internet. They're connected to each other. There's a lot of advanced tracking, and there's increased sort of online introspection. There's predictive maintenance, and so I think there's really a lot going on in Industry 4.0. Professor, is there a more specific question regarding sort of like this?
Yeah. So first of all, your involvement as a special invited talk to our BTech students in this current semester, which will be up to November.
I see.
Industry 4.0, Industry 4.0 or Business 4.0, whichever you prefer.
I see. I see. We're happy to sort of move the conversation to email and talk about it, I think.
Good. Thank you.
Thank you.
Okay, Naga, quick question from you, and I'll take just the last question. That will be by Priya.
Yeah, and because it is now 11:30 in night.
Yeah.
Yep, sure. Thanks, Rahul. Hi, Samir. So this question is more around solving the holistic problem of like automation, right? Like now, through robotics, we have a lot of ideas to automate, right? And we are getting there. Now, given that a lot of the students from our college typically move into the software domain, right, where they are involved in like system operations, etc. Right? Are we like further exploring any options to come up with the software like Automation Anywhere or any other tools which could sell as a platform, which would further automate the manual work which is being done by like some of the software developers or like system analysts?
Yeah, so for other people, to add some context, Automation Anywhere, was an initiative to have software-based automation. This is not sort of robotic automation.
Yep, software-based automation. Yeah.
Yeah, this is more like bots, like software bots that like chat bots or data stream processing bots and things like this. No, we are a little bit focused on robotics, so we're not working on these. And there's a lot of investment in automation and bots. It's in particular in the natural language processing space. There's just like a huge amount of investment. I have some friends who have startups working on this space. It is focused on, for instance, customer support, like answering, data flagging, classification, sentiment analysis.
Exactly. Yeah. It was AI and deep learning as well. Yes. Yeah. Yep. So actually, just to give some context, right, I've been working on this side of work for my company here. So I was like exploring in this option of like building the software on this. So that's why I just wanted to check with you. Thank you.
So,
good luck.
Yeah. So Dr. Kala, now please wrap up.
Okay, Priya, last question is yours.
Hello?
Yes.
Hello. I want to.
The audio is not good, so let me do the honor. Okay, I'll ask it on Priya's behalf. Priya, if you can mute. Yeah, I've done that. So Samir, you've solved so many challenging problems. And it is pretty sure you may have been stuck somewhere in between then. And what was your strategy to solve those unknown, unwanted problems that came up?
Oh man,
Dr. Kala, can you please repeat? I actually couldn't listen to you.
So the question is to Samir. You would have had so many challenges on the way in research, new problems you did not anticipate. How did you overcome those problems?
Basically, how if you have some unknown, unwanted problem, how do you solve it? This is the hardest question of any to answer. I think. There was one great professor, Professor Richard Feynman. He worked on quantum mechanics, and he has a very nice physics book. I think it's a 3-part book. But associated with Professor Feynman was a genius, and he was
that's why a couple of generations actually use that book. We use that book. You also use that book. The great opportunity. Yeah, go ahead.
And but he was so smart that some people came up with this idea that they called it the Feynman algorithm to solving extremely hard problems. And so the algorithm was go to a blackboard, then first write down the problem, right? Then look at the problem, then think like Professor Feynman, then write down the solution. So, I think hard problems. Human beings are creative. I think we all have our own mental models to solve problems. I think problems in different spaces have different strategies. There's I mean, if we knew how to solve unknown problems, like we would have already built an AI by now, because that's the essence of the human brain, is to solve complex, hard problems, and we don't know how to do it, unfortunately. But somehow, like magic, you sit down, you think hard, and like the great Professor Feynman, the solution comes into your head sometimes, and you write it down. So beyond that, it's difficult to answer this question.
Okay, wonderful. So, Professor Nand, okay, how are you? Okay, I'm sorry, I cannot take more questions. So, I think, Professor Nandi, I'll have you to present the vote of thanks and to conclude the session.
It is my proud privilege that we could listen Samir, Dr. Samir Menon. We spent, I think, 1.5 hours already for great interaction. He answered many questions, and main idea was to encourage our young minds. And as Samir told, that it's very difficult to find collaborators and find money. But Dr. Kala knows in India it is not so difficult. And it was surprising for me, government has came and they are telling, take some money to our institute and you just waste it. I told, what? How can we do that? Well, yes, if you have random idea, even then India has money. So it is not like that, because we need to make a jam start. Looking at the problems are all around us, and try to make a solution. And young minds who are aspiring to be an entrepreneurs like Dr. Menon, to try. In Indian context, there are many opportunities and success will be waiting for you. And I really thank Samir to introduce what he is doing. It's a wonderful job, very difficult job, very challenging job, and he has a wonderful team. And my best wishes that he will, in the near future, he will be having a grand success. And already he has achieved great success. Maybe one day he will be our Bill Gates or something like that, somebody like that. And then we'll feel very proud and happy. And today, as we are, and I also take this opportunity to thank Samir's family, because it is already approaching 12 in the night, and and it is really late. And but I thank you for your interaction, and the earliest opportunity you get, please visit us. This is your alma mater, and we have a great robotics laboratory here. We are trying to solve, sketching some of the problem only. In Indian context, we can do only that because our best mind are going somewhere. But still, we have many smart people with them. We are actually working. Thank you, Sumit, for your time. And Dr. Kala, thank you very much for wonderfully organizing this event and meticulously planning this program. This program is actually sponsored by the Center of Intelligent Robotics of our institute, then IIIT RAS UP section chapter with the jurisdiction of entire UP, Nepal, and some, I think, Uttarakhand. So many people across India are joining, and a couple of them from US also have joined. Okay, so thank you very much for making it very lively. Thank you.
Thank you, sir.
Okay, thank you, everyone. We conclude. Okay, bye.
Bye-bye.
Thank you, everyone.